Hi, I am Asanai Ebenezer Femi. I will be putting you through key techniques you need to understand in sampling distribution, estimation, and hypothesis testing. Let's go through this illustration before we proceed. Using Nigeria as an example, a researcher wants to know the average number of rich people in Nigeria. He thought of the fact that he cannot take experiment on the whole population to do his testing. He decided to focus only on Lagos, Enugu, Port Harcourt and Abia only, to make conclusions on the whole population. From the above we see that the researcher is trying to make a sample from the population and use his result to make conclusions on the whole population, which leads us to the above diagram. Nigeria is seen as the population, while the measures that is parameters we can draw from it are as follows: population mean, standard deviation, and so on. When we decide to pick some unit out of the population to make conclusions on what the population parameter can be, we are doing what is known as sampling. Lagos, Abia, Port Harcourt, and Enugu are seen as sample. From the sample we can draw a sample statistic as follows: sample mean, sample standard deviation, sample variance. The description of such a sample statistic is called an estimator of the population parameter. We can say sample statistic is also an estimator. Let's quickly evaluate some keynote before we proceed. Population proportion is the part of population we can express as a fraction, decimal or percentage of the whole population. For example, if 250 people have blue eyes out of 1,000 population, the population proportion can be given as 250 divided by 1,000 to give 0.25 or 25%. Similarly, sample proportion also works the same way. Just that in this case, we are trying to get the proportion based on our sample. If we are working with a sample size of 70, and the number of blue-eye people are 40, we can calculate our sample proportion to be 40 divided by 70 to give 0.57 or 57%. While point estimator are the functions we used in finding an approximate value of the population parameter, in this session we are going to be learning how to get our sample mean, sample standard deviation, sample proportion, which takes us to sampling distribution. It is the probability distribution of a statistic that is obtained through repeated sampling of a specific parts of the population. Let's move on to the sampling distribution of the sample mean. It is the probability distribution of all the possible values of the sample mean. To find the expected value of the sample mean, it is equal to the population mean as shown mathematically above. Now going on to getting the standard deviation, also known as the standard error. The above formulas are put into consideration. To know which formula to use in getting the sample standard deviation, we look if the population we are working with, whether it is finite, that is it is to an extent, but if it is infinite, can't be estimated or counted, you use the other formula. In another digression, when we have a finite population that is a known population, we can also choose to test if the infinite population formula will work. To do this, divide your sample size to your population size. If your result is lesser than or equal to 0.05, then you can use infinite population formula. But if it exceeds 0.05, you stick with the finite population formula. Real quick, let's take an example. Given the sample size is 50, the total population size as to 500, the population standard deviation as 4,000. Calculate the standard error. Note that standard error is also known as the standard deviation of the sample mean. As stated earlier in this course, even though we have a finite population, there is a need to test if we can use an infinite population formula to solve this. From the above solution, we see that after testing we got 0.02, which is less than 0.05, so we can use our infinite population formula, which gives us a standard error of 565.69. Basically, let's look at the sampling distribution of a sample proportion, denoted by p hat or p bar. The sample proportion, as said earlier in our keynote, it is like a point estimator of the population proportion. The sampling distribution of a sample proportion is seen as the probability distribution of all the possible values of all the sample proportion. The mean, also known as the expected value of the sample proportion, is equal to the population proportion. To calculate the standard deviation of the sample proportion, otherwise known as standard error of the sample proportion, the above formula is applied the same way it was applied in the standard deviation of sample mean. Now to estimation. This is the process of using numerical values of unknown population to draw conclusions on the population parameters from incomplete data known as sample. It is key to know that an estimator, also known as our sample statistic, is a measure or formula or rule we use while estimating, while an estimate can be seen as the end product of estimation. In the previous sessions, we've been able to see how to get our sample mean, proportional mean, sample standard deviation, and so on. because it is seen that we might be definitely not able to attain the real population parameter we are trying to get. There is need for estimation. Types of estimate. Number 1 is point estimate. It is to be noted that the point estimator, or sample statistic, is used while estimating population parameter. So, the point estimate is the single value gotten from sample statistic of an unknown population parameter. It should be noted that point estimate is also known as the sample mean. But because the point estimate may or may not give the exact value to be used for the population parameter, we introduce what we know as interval estimate. Interval estimate allows us to give range of values while using margin of error to help us estimate the population parameter in a more likely way. The general form for interval estimate for the population mean is shown above. Let's take a look at what margin of error entails. The margin of error is seen as the degree of tolerance or uncertainty in our test or study, since the point estimate tends not to be given the real population mean estimate, which leads us to use the margin of error to have an interval estimate, which our population mean will fall in between while using the sample mean. Put in mind that earlier in sampling distribution, we gave our standard error to be the population standard deviation divided by the square root of sample size. To calculate the margin of error, we are to put in mind these three key things. First, is the population standard deviation known? Second, is the population standard deviation unknown? Third, are we working with population proportion? Starting with the first, in the application of this in this chapter, we will assume our distribution to be normally distributed, so that we can be able to compare as we go on. The above is the general form and meaning of each elements.